Hello, we are going to now do 7.2 of the 56th part of the course, and this is about the quadratic formula, which is probably one of the most beautiful and powerful formulas in mathematics. Now, in order to use the quadratic formula, we have to put all of our equations in the form of which was standard form, ax squared plus or minus bx plus or minus c is equal to 0. And recall that this is standard form. So in order to use the quadratic formula, our equations must be in this form. And we're going to find the roots, or what x is. And because it's squared, we're going to have actually two answers. So the formula is given as follows. And because, as I just mentioned, it has two answers, that's what the plus or minus means. This gives plus this, and then we also do subtracting that. And a, b, and c are real numbers. So as I said, we first write our equation in the standard form. We then find the values of this equation. Once we get in standard form, what is A, what is B, what is C, and then we substitute these values into the quadratic formula and simplify as much as we can. So for example 1, let's look at this one. So we have x squared plus 5x plus 6 is equal to 0. So we're going to write our equation, and what I'm going to do is put the general quadratic formula underneath to show where A is. This is A, B, and C, and so we list it where A, if you don't see any number before this, you assume that is equal to 1, and we see B is equal to 5, and C is equal to 6. We then take A, B, and C and plug it into the quadratic formula. So we get, after we plug B, which is 5, and 5 for the B's, and then here for A, 1 for the A, and C, 6, all over, not just the square root part, but the entire top part is over 2a, and in this case a is equal to 1. And then we just proceed to solve it. So we have 5 squared is 25 minus 4 times 6, well, times 1 is equal to 24, and then that's all 2 times 1 is just 2. So here we have, and this tells us that there are two answers, because we know the square root of 1 is 1, so it's going to be, the two answers are going to be negative 5 plus 1 over 2, and then negative 5 minus 1 over 2. Well, negative 5 plus 1 over 2 is negative 4 over 2. And that gives us negative 4 over 2 gives us negative 2. And then negative 5 minus 1 over 2, well, negative 5 minus 1 is negative 6. And then divide negative 6 by 2, and you get negative 3. All right, for example number 2, let's look at example number 2. And it asks us, what are the solutions of this particular quadratic? So we're going to actually use the quadratic equation for this because we have a big number here. So maybe it would be best to use the quadratic equation. We could perhaps use the other methods that we've learned to solve for x. But the thing about the quadratic equation is that it works for all equations. So we don't have to worry about the AC method, or we have to worry about some of the other methods that we've learned. So Here we're going to actually just use the quadratic equation. So as before, we have it in standard form, so all we have to do is define A, B, and C. So there we have A is equal to 1, B is equal to -2, C is equal to -48. And as before, we just plug it into our quadratic equation. Where we see the B's, we put the -2. Where we see the A's, we put the 1. And the C, we put the -48. And solve as usual in order to get our two answers. And it turns out that 196, the square root of 196, is a perfect square, so we end up with 2 plus or minus 14 over 2, and then we have our two answers. 14 plus 2 over 2 is equal to 16 over 2, and that gives us 8. And then for the minus one, we have 2 minus 14 over 2, and that gives us -12 over 2, and this gives us -6. So our solution set is 8 and -6. Similarly, for example number 3, but this time we have our A is not 1 but 2. So again, we designate which our A. Our B turns out to be -1, and our C is -5, as displayed here. And again, as before, we plug it into our quadratic equation. Where we see B, we'll put -1. Where we see A, we will put 2. And where we see C, we'll put -5. And then solve as usual. So here we get 1 plus or minus the square root of 41. So therefore, the solution set is 1 plus the square root of 41 over 4, and 1 minus the square root of 41 over 4. So you see here, sometimes you have fractional answers. So remember that fractions do happen. And so now here we have example 4. And we see the 0 is on this side of the equation. But it doesn't matter which side of the equation it's on, it's still in standard form. So whether we have 0 on the right side or it's equal to 0 on the left side, that doesn't matter because we can still designate A and B as usual. So we have our quadratic formula. And here it turns out that A is equal to 2, B is equal to 4, and here C is equal to -1. So as before, we just plug it in to our quadratic formula, and then we solve, use the radical, and then we do, after we finish the radical part, we add and subtract accordingly. Reduce, here we're going to reduce because 24 is 4 times 6, so that means we can pull out a 2 and get the square root of 6. Remember, it's important, if you can, simplify the radical. And here we have, there it turns out that 2 goes into all of these, so that means that we can get rid of the 2 goes into 2, 2 goes into 4 2 times, 2 goes into 4 2 times, so we simplify it to this, since, as mentioned, these are all divisible by 2 and therefore can be reduced. So we have our final solution set is -2 plus the square root of 6 over 2, and then of course -2 minus the square root of 6 over 2. In example 5, here we have another quadratic formula. And of course, we can maybe do it by the AC method, but it may turn out that we'll get fractions or something complicated. So, and plus we have that so we want to see, it's probably easiest to solve this using the quadratic formula. So again, we have this already in standard form. So we have A is equal to 6, B is equal to 7, C is equal to -5, and then we just put it into our formula and we solve for x. We do the stuff under the radical sign first, and we do that, and then we have 169, and it turns out the square root of 169 is a perfect square. So there we have -7 plus 13 over 12, or -7 minus 13 over 12. So the solution set is -5 over 3, comma, 1/2. So those are the two possible solutions that we could have for this particular equation. And there's the solution set written out. For example number 6, we're going to solve this. Again, maybe we can use an AC method, but we don't know if it's going to be nice and easy and everything is going to work out nicely. So it's probably always best to use the quadratic formula in something like this. So, because this is solving. So here we have it. It's in standard form. So we're going to designate A is 11, B is -9, C, there's C, -1, and then we plug it into our quadratic formula, and then solve under the radical sign first. And remember, we're going to be dividing this whole thing. So it's going to be 9 plus or minus the square root of 125, nice perfect square. Well, that's not a perfect square, but there's a perfect square hidden in here. And then this all over 22. And there we have 5 square root of 5, because this is 25 times 5. And we have 9 plus or minus 5 square root of 5 over 22. And we cannot reduce this any further, so the solution set becomes these two. So this would be kind of a really difficult to solve if we tried to do it using an AC method and then setting each part equal to 0. Now in example 7 here, we have something a little bit more complicated. So I'm going to go to the whiteboard now and show you this in more detail than this PowerPoint is going to show. So let's go to the whiteboard. All right, let's look at example number 7. And in this example, which I'm going to write out because I didn't put the whole clearing the fraction on the PowerPoint, we're going to look at 1 over 8 x squared plus x minus 5 over 2 is equal to 0. So we see that indeed that's in our standard form, which is exactly what we want. But we have these fractions, so we want to use the technique of clearing the fractions. So in this case, the lowest common denominator is equal to, say, 8 over 1. So that means when we multiply through the whole thing by 8 over 1, we get x squared plus 8x minus, and then of course 2 goes into 8 4 times, and 4 times 5 is 20, equal to 0. So now we have it in our proper form, and now we can designate A is equal to 1, B is equal to 8, C is equal to negative 20. And now we can take that and put it into our quadratic formula. So that's going to be equal to negative 8 square root of 8 squared minus 4AC. A is 1, C is negative 20. So close that. And this is, oh, I forgot the plus and minus. Ooh, very important. Must put that plus or minus there. Very, very important, plus or minus. And that's all over 2 times 1, which is 2A. And remember, we have to put everything, this part and this part, over 2 times A, or in this case, 2 times 1. So then we proceed to solve it. 8 plus or minus, because those are going to give us our two answers, will help us establish what they are. 64 plus 80 all over 2, and that's going to give us negative 8 plus or minus the square root of 144 all over 2, and that's going to give us negative 8 plus or minus 12 over 2, and that'll establish our two answers. So we have negative 8 plus 12 over 2, and then our other answer is going to be negative 8 minus 12 over 2. And so this one is equal to negative 8 and 12 is going to be 4 over 2. So that's going to be equal to 2. And then here we have 20, negative 20 over 2, and that will give us negative 10. So that means that our solution set will be equal to negative 10 and 2, and that is our answer. So as you see in the PowerPoint in example number 7, which is written a lot neater than my handwriting, the solution indeed, we clear that fraction like I said on the whiteboard, and we define A, B, and C, plug it into our quadratic equation, and we see that here we have that perfect square, and so there we have the negative 10 or 2, and that becomes our solution set, just like was done on the whiteboard. Now for example 8, I'm actually going to do this one on the whiteboard also, because I'm going to work it out in a little more detail than I worked it out on the PowerPoint. So let's turn to the whiteboard. All right, we're going to now look at example number 8, which also has a few more things going on. So I'm going to do it in greater detail than is done in the PowerPoint, as I did with example number 7. So I have x plus x6 is equal to negative 30. And as you see, this is not in standard form, because standard form tells us it has to be ax squared plus or minus bx plus or minus c is equal to 0. So we have to here, in order to get it into this form, we have to use our distributive property. So we have now x squared plus 6x is equal to negative 30. But it's still not in that right form. Okay. It's still not quite in the right form because we have to bring this over here. So now we have to do x squared plus 6x plus 30 is equal to 0. And now it's in the right form. So now we can designate a is equal to 1 because there's no number in front of it, so we assume it's 1. B is equal to 6, and C is equal to 30. Now we can plug those numbers into our quadratic formula. So our quadratic formula is x is equal to negative b, and we have b is equal to 6, so that's negative 6 plus or minus square root of negative 6 squared. Well, not negative 6, we have a positive 6 there, so 6 squared minus 4, a is 1, and c is 30, all over 2a, where a is equal to 1. And then we proceed to solve that. Negative 6 plus or minus the square root of 36 minus 120, all over, now remember, it's over the whole thing, 2. So that's going to give us negative 6 plus or minus the square root of negative 84, all over 2. Now we see, if you notice here, that we have a negative under the radical sign. So that tells us that our answer is going to be a complex number. So this means we have negative 6 plus or minus I square root of 84 all over 2. So our solution set will be negative 6 plus I square root of 84 all over 2. And then the other one is negative 6 minus I square root of 84 over 2. So this means there are no real solutions. So the solutions that we have here are complex solutions. So now looking at the PowerPoint and solving this example, and we see indeed I worked it out, but I worked it out more detail on the whiteboard, and we find A, B, and C, put it into the quadratic equation, and solve it, and we find, there are no real solutions. And as I mentioned on the whiteboard, yes, there are complex solutions, but there are no real solutions. So, thank you very much, and stay well, and I hope you enjoyed this whiteboard PowerPoint version of the lecture, and be well. Bye.